Good afternoon everyone. Today we will be looking into a topic called making IoT devices smart using artificial intelligence. My name is, as introduced, Praveen Hanchinal. You can just Google up my name. You can just explore more about me on my website also. I'm into a lot of things like regarding IoT, AI and blockchain and all. You can just Google up. Okay. So let's see what actually we will be discussing today. So what are IoT and AI in very simpler terms, like in a very crude basic way. Then what makes the device an IoT, then what are smart devices, what is this AI, ML and DL are, then how these AI models are created. Okay, so I'll just show you a small demonstration out of it. Then how these AI models are deployed into IoT devices, then artificial intelligence in relation to IoT and big data. Then we'll also look at the challenges and dangers faced regarding this. Before proceeding ahead, we'll verify whether we are using IoT devices. The first foremost device which we are using is phone. So it goes without saying that like phone is an IoT device, but it is connected to internet. Then our smart TVs are like also an IoT devices. Laptops, PCs comes without questioning. Then we have this smart cars now. Okay. Then if just check whether we are using AI. Most of you have observed, I guess, like day by day as phones are getting newer versions. The face is same, but the point here is people are looking more beautiful and beautiful whenever they buy a new phone. The reason is AI models has been plugged into the camera app so that they will verify your faces, like they will check your faces, they will mark the points, and they will decide like what's the best algorithm to get the things done. Okay, so in what way they can enhance, make it the photos more beautiful, something like that. Then I don't know whether you have observed it or like I'll use Gmail's autocomplete a lot. Like for example, if you say just type thank you, it will autocomplete it as regards, like you also mention your name, something like that. So this is also an example for AI. So and whenever like I explore a lot of foreign countries films and all, so in YouTube and all, whenever we get those kind of stuffs, it will auto translate it for me. Then I can watch that any foreign French language or even Dutch, so that kind of languages can be watched in the YouTube. Okay, so just by using Google Translate. So Google Translate is also an example for AI in implementation. So next another prediction, like in phones, whenever you type the text and all, I hope you have observed like whenever you do the frequent steps, it will autocomplete it for you. So it has been doing this since 2018. In 2018, Google I/O something called federated learning. So what this federated learning actually means is it will take the location specific suggestions. Okay, so it will assume that like you will be using those kind of words in your text. Okay, so whenever you type that, like that will be auto completed in your phone. Okay, so similarly Google Lens is top notch now, so it will automatically detect a lot of stuffs. It can be barcode, QR codes, even any kind of to be searched, those kind of things will come under this Google Lens. Then if I have to give this Gartner cycle, you can see this is over 2017. Okay, so in 2017, if you look at the top emerging technologies, this IoT is there, machine learning is there, deep learning is there, is on the top. Okay, so if I come over to 2019 also, again you can see this edge analytics, this AI pass, again IoT will all come under the top. Okay, so the point here is things will fall into place. So IoT is unavoidable, even the machine learning AI technology is also unavoidable. So first the point here is why we need smart devices. So that's a question we have to question ourselves. Okay, so if you look at this graph, it's a prediction graph. So if you go ahead by like 2025 something like that, even 2025 to 50, so they are expecting more than 50 billion devices to be on the internet. Okay, so that is like all these things will be of IoT stuff. For example, it may be cars, it can be washing machine, it can be hair dryer, it can be anything in your home. Okay, so that will be plugged, it will have a small chip, it will behave like a IoT device. Okay, so this is one idea. So next point, very important point is, I know this is silly, but actually that is what consultation is all about, because people are stupid and lazy. So this is another reason where we need this smart devices. So the point here is people behave stupid way. So to avoid that, like things have come, automated things have come. So in the similar way, smart devices will also assist like stupid people or like lazy people. Okay. Then you can see in this image like automated doors has been launched. Okay, but still again people behave stupid way. So now we have to use some machine learning or artificial intelligence to help her. Okay, so now if I look like into the roads and all, okay, so you can see like there are a lot of people in India and all who don't follow the traffic guidelines. Okay, so it becomes very hard for the people who follow it. Okay, so that's the reason why we need this AI powered smart cars. Okay, so even if whether it is assisted smart car or whether it is independent self-driving car, so that goes without saying, by 2050 or something like that, we need like cars which follow the basic traffic rules. So that is also a need of the hour. Okay, so next very most important point is population. Okay, so whenever there is a population, we have problems. Okay, so we have a lot of problems regarding food, we have a lot of problems regarding healthcare, we have a lot of problems regarding comfort. Corporate tries to make money by solving these problems. Okay, so for example, Amazon is an example which like globalized e-commerce. Okay, so in a similar way, then we have something called human brain limitations, like humans cannot like more than 20 hours, something like that. So there is a one point, even they get bored like working on the same task, something like that. So to find the solution for this, okay, there are a lot of boring stuffs. To solve this problem, we have to automate the things. Okay, so if you automate the most of the boring stuffs, okay, it becomes easy for us to handle the things. Okay, that is the idea of this population to problems. Then comes the question how to automate. Okay, so the best idea is to use something called microcontrollers. Okay, so I'm not talking about microprocessors. Understand, here we are talking about microcontrollers. Okay, so what actually microcontrollers will do is they will have a simple code or like a simple instruction set. Okay, so these will be plugged into devices. Okay, so those devices can be controlled or like handled using automation. Okay, so I'll just give one small example. Lift is an example for this. Okay, so lift will have something called microcontroller. So it is already being programmed. Okay, whenever you press particular button, it will go to particular floor. Okay, so we cannot expect any intelligence in that. Okay, so it's a straightforward computer like basic baby computer stuff like that. Okay, so microcontroller is a option which we have like to automate it. Okay, so once we have this automation using microcontrollers, these devices can be connected to internet. Okay, so for example, Arduino can be connected to internet, your phone can be connected to internet. So if that happens, so if the things are getting connected to internet, that will become IoT. Okay, so I hope you are with me. So what actually is an IoT is internet plus things. There are things which are controlled by microcontroller or handled by microcontrollers, or that are connected to internet. So it's a very basic crude way of explaining the IoT. Okay, so then these interconnection of devices or everyday objects is very important so that we have a peaceful life. Okay, so that's the idea of IoT. Okay, then why we need this IoT? So the first foremost idea of having an IoT is to receive the data or collect the data. Then we have to control the things. So it may be factory or it may be your home, it can be your TV, so or your production line in a factory. So then we have to automate it in the sense like I don't want to intervene. I'll just give an example. Whenever I launch Amazon Prime on my phone, my TV has to automatically start. There is something called Chromecast where a particular movie which is being like searched in my phone should be launched in the TV and automatically should be like played. That is an example for automate. Similarly, things can be done in the factory also. Then we should build something called build smart environments. I hope you have heard about some recent very groundbreaking words like smart cities and all. So the idea of smart cities is to all the IoT devices will be connected to internet. So every possible thing will be connected to each other. So because of that, like you will have full control over this city. So once you are able to control the whole city using the internet, so that will become an example for smart environments. Okay. Then if I have go to a little bit deeper, so you have something called IoT architecture. The idea is first we have sensors. So whenever there are sensors, these sensors will collect and send the data. So to send the data or connect the data, so we have to have something called network layer. It can be Bluetooth, Wi-Fi, okay, Zigbee, anything, any protocol. Then we have something called processing unit. That is like if you have Raspberry kind of devices, that will process the things. It will identify whether there is a face or not, something like that. Then after that we have this application layer where you should be able to control a farm equipment, something like a motor water pumping motor in my farmhouse sitting over like 100 kilometers apart. Okay, so that's the idea of application layer. So this goes hand in hand. Okay, but the point here is these sensors and actuators are most important in this IoT. Okay, so IoT, if we have to put it in a very equation format, so it's about first sensing, communication and computation. So sensing, the sensors, RFIDs, QR codes will be there, so they will collect the data for you. Then whenever you collect any data, so you have to communicate. Say for example, if I take any QR code, this QR code will connect to internet and go to the particular website, like that. Or if even if there is a QR code for in a metro, so it has to scan and verify that like this is a verified QR code from a particular server has been generated. So that can be done in this communication. You can use many protocols. Okay, so popularly they may use nowadays like Wi-Fi has replaced everything, but still there is a room for this PAN as well as Bluetooth, even Zigbee. Okay, then we need something called computation. So there is something called edge computing, in the sense most of the data need not to be sent to the server. I'll just give you a small example. In your phone you have something called accelerometer. Okay, so there are like more than 30 to 35 sensors in your phone right now. Okay, so these phone sensors, even if you are just holding it, it will generate a lot of data. Okay, so even if you just take one sensor just by tilting your phone, just it will understand like it will generate at least 10 KB of data, something like that. So that data, if you keep on like continuously like use the phone like for long duration, your phone will be shaking, something like that. So you have to multiply it by number of seconds, multiplied by number of hours, minutes, something like that. Next point here is, if for example, if I have to track how much of hours you are sleeping, then I don't need all the whole day's data from you. Okay, so basically we'll assume that like people will sleep from evening 8 or 9 to morning 6, something like that. Then I should collect only data of that accelerometer or like device sensor, like or moving sensors, only from 9 to morning 6 o'clock. So then I can reduce the number of like data points to be collected or data collected. Okay, so that will come under something called computation. So this will also look for something like NFC devices and all, so which things are connected, so that all will come under computation. Okay, so IoT is about sensing. Okay, then we have communication, then we have computation. Okay, then in sensing I'll just go a little bit deeper. So how to receive data? The first thing is we have to measure the values. Okay, so we have to send the data. Okay, how to collect it and send the data, and you should work on very low power, very important. Okay, so this last point is most important for us, because if the IoT devices consumes a lot of power, it becomes very difficult for us to manage the power. Okay, so they should work on very low power, in the sense like if you take your Bluetooth devices and all, they will work in very low power mode. Okay, so even if you charge it for once, it has to come for at least 10 days, something like that. So similarly, these IoT devices, sensors, we have to work on very low power. Okay, then you have communication. In communication, we have something called IoT gateway. Say for example, if I install 4 CCTV cameras in my farmhouse, so these all cameras will be connected to a Wi-Fi, so that in turn will be connected to something called Raspberry Pi. So if there is some like object intrusion in my farmhouse, so definitely it will notify with a picture of a particular camera, something like that. So it has to, the idea of the communication is to network and internet. So it has to gather data from the sensors. Okay, so popular protocols used are MQTT and XMPP. Here they don't use HTTP because HTTP is having higher payload. Okay, so the more payload, the more data will be consumed. Okay, the idea is we have to send the data, but we have to send it in a very minimal format, in the sense only what is required has to be sent. So that is the reason popular protocol here used is MQTT. Okay, so there are a lot of synonymous terms which they will use. Sometimes they will call it as fog computing, edge computing, something like that. So these in turn will be connected to a particular cloud, and you will monitor the devices from remote location. Then in computation, the idea is you have to process the gathered data. So see, for example, if you ask for a sensors to collect the temperature, so now as in winter, imagine like the temperature lies between 20 to max of 30. Okay, so imagine like there is a faulty sensor and instantly it triggers a sensor value as 50. So we know that it's a winter, like obviously the temperature cannot go beyond 50 like that. So then we have to eliminate that. So those kind of things can be done here. That is, if you have collected the data, you can eliminate the processed, like get, which is not important for you. Okay, so you can upload only data which is valuable for you. So for example, if there are values, 20 values which are having same value, say for example 25, 25, 25 like this up to 20 times. Okay, so we don't need to enter 25 like 20 times, you just have to like upload it only once. So that can also be done. Okay, so upload only some data, not all data. Okay, that's the idea. Then question comes, is automation enough? So why I'm saying this is, see, automation is not about like a machine which takes decisions on its own. Okay, so the point here is there will be a robot. Okay, so if that robot understands the task of like stacking things, say on the slide, I hope you can see on the right hand side, what the robot is actually doing is it is stacking the stones one above the another, like how kids will do. Okay, so this example is an example for like automation is not enough itself. Okay, because if I program this robot for particular stones, if I replace these stones by something else, it will have a very hard time, in the sense it may not be able to do the stacking for it. Okay, so that's the reason why automation is not enough. Okay, so and whenever you do automation, so that means it's monotonous, in the sense it will go in a default way and there are pre-described instructions. So this will work only when, like say for example, if you want to scan a QR code of a ticket and you just have to verify and send it to a particular server, by that time automation will be enough for you. Okay, but imagine like all the metro services and all will scan your face in real time, then they will allocate a ticket for you, then you will send it to particular server or cloud, something like that. By that time automation will be not enough. But the point here is, people may not show the face exactly how the camera is looking for it. Okay, so because even if you take a selfie 100 times, each of the time your face will be in a different particular position itself. Okay, so it becomes very hard for the cameras to identify that is you, only you. Okay, so that is the reason this automation will not enough for us. Okay, so automation will make us life easy, there is no question about that, but in terms of like if you think about long term, this automation will not enough. Okay, so that's the reason we have something called artificial intelligence. Okay, now to help you understand how this IoT requires artificial intelligence, I'll just give you a bad example. So I have disclaimer like right now only that it is a bad example, but the idea is it will help you to understand the things. Okay, so what actually happens here is, imagine like there is a urinals in the airport. Okay, so in airports and all, you can see there is something called automated flushing. Okay, so I am talking about devices which flush the water, okay, for particular duration of time. Okay, that is IoT devices are there, like not only IoT, just we can say automated controllers. Okay, so controllers will be there, okay, for each urinals. What they will have a sensor, that is something like object sensor. Okay, whenever somebody stands before the urinals, okay, so what it will identify is like somebody is standing before me. So once you move off, so again it will understand like move off has been done. Okay, so then it will flush the water. But the interesting point here is, most of these controllers are for prefixed time, in the sense they will flush the water for like approximately 40 seconds, something like that, for 30 to 40 seconds, and it is fixed. Okay, so what the idea of fixed means, so it will never change the seconds value. So whichever urinal is there, and like it does not depend on the person itself. See, for example, I'll just give an example. Imagine there is a person who will go to washroom, who will like stand before the urinals, but he don't pee, in the sense like he will not give any performance there. So but actually even if he goes off, this urinals think that okay, acha, like he has actually urinated, I need to flush it. This is the example of wastage of water. Okay, and there are people who will stand for 1 minute to urinate. Okay, there are people who will finish off in just 15 seconds. So the amount of urine passed from particular person to this urinals differs, and there will be people who have fat body and all, who will consume a lot of water, and they will be urinating longer duration. So that depends. So that's the point. This IoT, if automated, if you install microcontroller and if you don't apply artificial intelligence or machine learning, this creates a lot of problem for the particular airport company, something like that. That is, it will waste more water. Actually, this actually is not a case study, but the idea is it will help you understand that IoT actually requires artificial intelligence. Using artificial intelligence, we can train the model, particular model, then we can tell that particular microcontroller or microprocessor, then we can tell it to decide based on the amount or weight of the person, particular something like that. We can decide how much water to be flushed. The conclusion here is IoT devices require artificial intelligence to have smart things. Okay, then comes what is AI. Okay, so I'll just keep it very simple. AI is all about the science of intelligent programs. That's it. Okay, so we have a traditional programming method. Okay, so we were coding it, but now we have to code it in an intelligent way. Okay, now what's the brain of AI? What AI underlies the AI is the neural networks. So what actually happens in neural, you have an input layer, then you have something called hidden layers, then you have an output layer. Okay, then I'll just go deeper into this as time goes by. Then we have something called map plus bio, in the sense this idea of this neurons has been adopted from biology. Okay, so cell body is an example for this summation function. Then we have something called synapses. So these weights will be allocated. Okay, so based upon this axon activation function and all, so you will get some output. Okay, so it's a combination of mathematics and biology. Okay, so you can say some statistics stuff is also involved. Okay, so here is a very simpler example to understand the previous pictures. So what we can do is we can ask a machine learning model or artificial intelligence model to define a cat or a dog. Okay, so both the animals are having some specific characteristics, in the sense both are having 4 legs, 1 head and 1 tail. Okay, so and both move in a very particular direction. But the idea of the cat here is cat does not have an elongated mouth. Okay, so whereas dog has. Dog ears are a little bit different compared to cat. So what we can do is we can give hundreds of cats and hundreds of dogs images. Then we will ask it to learn itself, decide what all the things we will be learning from this picture. Then after once it has learned done the things of learning, then we will show a particular cat or dog face. Then it has to understand whether it is a cat or dog. Okay, so in a very simpler terms, it's like training a baby how we would like to proceed with the examples of cat and dog. For example, whenever your cat comes, you will show him this is cat. Whenever a dog comes, then we will show you this is a dog. So every time you will keep on increasing his database set, in the sense you will show lot of pictures of cats, lots of pictures of dog, so that baby learns that by whenever a new kind of dog will come, it will identify the characteristics that this is a dog or cat itself. Okay, so there is no confusion regarding this. This is how machine learning works. Okay, so let's come to another particular word called deep learning, machine learning and deep learning. So I have made this conclusion with vast learning. Okay, so there are a lot of very complicated terms associated in Wikipedia, even in some DZone and all. The idea here is artificial intelligence is a human intelligence exhibited by machines. That's it. Okay, so there is no confusion at all. Okay, so what AI is a human intelligence exhibited by machines. Then what is machine learning is, it's an approach to achieve artificial intelligence. Now I have to achieve artificial intelligence. So what is the way I can do is using machine learning. Okay, so it's an approach to achieve artificial intelligence. Then you have something called deep learning. Okay, so the deep learning is a technique which we implemented for machine learning. Okay, so artificial intelligence is a human intelligence, whereas machine learning is an approach, deep learning is a technique. Okay, so don't get confused. There are a lot of jumbled up too many words in the internet. Okay, So this is the most simplest which I have come for according to me. Okay, so let's understand. We understood that like machine learning lies the basic essential thing for the to achieve artificial intelligence. Okay, so let's understand machine learning. Okay, before understanding machine learning, so let's understand how computers work, that is how machines work. Machine in the sense computers. Okay, I know you already know this stuff, okay, but I am putting it in a very different way, so that's the idea. Okay, so if you understand this point, it becomes very easy for you to understand machine learning. Okay, so bear with me. You may be like blaming me or scolding me for taking a very raw example, but like have patience for 2 minutes. Imagine there is a baby computer. So I am talking about a computer which is in very crude form. Okay, so like 2-year-old computer baby. Okay, so now the task for this computer is it has to go to the shop. Okay, it has to get me a Oreo biscuit bundle. Okay, I hope this is clear. So I have a baby computer with me. Though this baby computer has to walk towards the shop. First instruction is take 100 rupees. Second instruction is go to computer shop. Third instruction is get me a Oreo biscuit. Fourth instruction is come back. What will happen if the shop is closed? What may happen? Like what this computer will do? Any ideas? We have not given any instructions that what you should do if the shop is closed. Because of that, this computer, baby computer, will stay before the shop forever, infinite loop. So that is the idea. Then once the biscuit bundle is obtained, okay, so the next question is whether it will ask for the change. The idea here is whether that baby computer will ask for the change with the shopkeeper. Okay, so again the point here is it will not ask for the change. Why? Means we have not instructed to ask for the change. Okay, so the idea is it will just go to the shop, take the biscuit bundle, come back. While coming back, there is a ditch. Okay, so on the way back to the home, so there is a very big drench or ditch which has been built, dug up by some JCB. Okay, or by the meantime it was returning. So now the question comes is whether this computer should fall into the ditch or should it jump. So if it is a good computer, what it should do? So the idea here is if it is a good computer, it should definitely fall into the ditch. Suppose if your computer jumps for the ditch, then there is a fault. It is faulty in the sense it is not behaving as instructed to do. So that's the point. Okay, so I hope you got this. So this is what I'm trying to make you understand, it has to do only what is instructed to do. Okay, so now let's go deeper into this machine learning. Okay, so traditional programming, so we had some data, so we had some program. Okay, there was a computer, we are getting output. Very simpler. 2 and 2 is the data, plus is the program. In the sense addition is a program we actually are trying to write. Okay, so data is 2 and 2, program is addition. Okay, so the output will be 4. In machine learning, a little bit reverse, in the sense we have given the data as 2 and 2, we have given the output as 4, but it has to figure out the program that it is addition. Okay, but the idea in machine learning is it will not figure it out as addition. It will understand that it is similar to addition. That's the idea. Okay, so if you give the output as 0, it will understand that it is similar to subtraction but not exactly subtraction. So that is how we go in machine learning. Okay, so here 2 and 2 is given, output 4 is given, program will figure out, that is computer will figure it out that the operation which we are trying to perform is addition. Okay, so in traditional we are giving very specific instructions. So I'll just go a little bit in a abstract way. Answers will be there, data will be given, that is output is given, data is given. Then machine learning has to understand what are the rules, that is addition is there. Then in the other way, once this is understood by the machine, we will give some input data, then it will check whether it understand what it learnt is addition or not. Okay, so that is the idea of this machine learning. Okay, so then comes why this machine learning is very important for the daily life. Let's understand in a coding, as we are all computer science, well, let's go into coding format. So whenever you write code for walking, Imagine like there is a wristband, something like MI Fit band or something like Apple watches and all. So how this Apple watch understands whether I'm walking, running, okay, so doing all those kind of stuffs. What they will do is, while he is walking, what they will do is they will calculate the speed based on the GPS stuff and all, speedometer and all. So if the speed is less than 4, the status will be walking. Very simple. Okay. Whereas if he is running, speed should be less than 4. Okay. So if the speed is less than 4, status is walking. Else status will be running. Okay. Then if somebody like actually is biking, okay, speed is less than 4, walking. Else if speed is less than 12, running. Else if the speed is far more, okay, then it is biking. Okay. So this is how actually we were writing code. Okay. So in a traditional way, we were writing like this. Now what you will write for this? Okay. So this is a headache in the sense, in golf there is no predefined motions. In running you had some pace, in walking you had some pace, in biking you had some space. In golf it is totally confusion. In the sense, we don't know. Each player has its own like identity. Each will swing the golf stick with a particular momentum. Each has its own. Every person has its own way of standing for hitting a ball. Okay, so it becomes very confusing. What to write? Okay, so similarly this happens for badminton also. Okay, so that's the reason your phone will detect all these activities like sleeping, running, and walking easily. The reason is it's very straightforward programming, whereas golf is a very complicated one. So this is the idea. So if the zeros or ones are like this, okay, I am talking very like deeper level, binary level. So if the zeros or ones are like this, label it as walking. If the zeros and ones are like this, running. If the zeros or ones are like this, biking. Now what we do is, we will tell the computer that if the zeros and ones will fall something like this, say it is not golfing, sort of golfing. If computer learns by actions, okay, so that will be machine learning. Okay, so if it follows rules, then it is traditional programming or like without machine learning. Okay, so I'll just give you an example so that you can understand. Imagine like I have a computer which go by the rules of the RTO. It will drive on the left side of the road, it will stop at the red signal, and it will slow down at the hump, something like that. So that is RTO has given very specific rule book for you. That is, whenever there is a parking P, you have to park there. Whenever there is a speed limit of 40, you have to like drive in a 40 km/h speed, like that. So if you go by the instructions book of the RTO, if you follow the rules, it is without machine learning. What actually happens in machine learning is, you will feed it the data, in the sense there is no rule book given for you. Everybody is driving on their own on the road. Okay, so what you do is, how will you figure out what is the best way of driving on the road? Okay, so what you should do is, you will take your bike, you just randomly ride on the road. Okay, for example, on the right side of the road. If you are riding it on the right side of the road, somebody will come and hit you. So that's the indication that like you are actually doing it in a wrong way. Okay, again, if you go a particular speed, if there is a hump signal, if you don't understand that, you just jump the hump, then obviously there will be a jerk for your machine on your body. So then you will understand that, acha, this is not the right way of crossing the hump, then I should slow down, something like that. So day by day, based on your experiences on the road, you will start learning. So that is the idea of machine learning. So that is how you should make our computers to learn. Okay, so I'll just give you a demonstration regarding this so that you can understand. Okay, so I'll just again go deeper into this. AI, machine learning, DL. Okay, so each one is a subset of each other. Okay, if a car just decides if there is a hump, it has to slow down, something like that, that is artificial intelligence. If a car learns day by day, like it will go by a particular road daily. Okay, so then it will understand, today I went for 40 km/h, then there will be a jerk on the hump. Okay, today I'll try to reduce by 20, then it will understand like a hump is like smoother now, like that. Then it will keep on doing that for like 1 month. That is machine learning. Okay, so if just car knows if there is a hump, if car slows down, that is artificial intelligence. If the car decides to learn day by day, then it will slow down, then that is an example for machine learning. what deep learning actually is, all the cars in the whole city will have the data of particular hump size, like what is the speed that has to be crossed, and all the data in that particular cars is aggregated to some server, and server will do some analysis on deep data, okay, this huge data collected, and it will send back to all the cars that this is a particular road you are moving, this is a speed you should go. So if that instruction is coming, that is the example for deep learning. That is, all cars aggregate together, share the data, do the analysis, and they will learn. That is the example for deep learning. So machine learning above that, artificial intelligence on the top. Okay, so what actually you see from all the devices is AI. Okay, so in turn, like in the engineering, what actually engine is machine learning. Okay, so inside this, what actually the piston is moving is deep learning. Okay, so this is how the subset each other. Okay, so types of machine learning. Okay, so just giving an idea. Supervised actually stands for train me. So what actually it says is train me. Okay, so unsupervised learning says I am self-sufficient in learning, so you just give me data. Okay, reinforcement learning says there is no rules at all, in the sense my life, my rules, that kind of hit and trial method. Okay, so this is supervised learning. You want to make your computer learn. Okay, what you do is you will label the data and you hold it and drag it towards the end. So that is the example for supervised learning. That is, you label the data and you will control it. Then in unsupervised learning, again similar things, but the thing is you will not hold it here. Okay, so it will try to figure it on its own. What's the idea? So in reinforcement learning, whenever a kid walks, you will give him a cookie, so he will understand, like, whenever I walk properly, there is a reward. So suppose if he falls, you will pat on his back, in the sense this is not the right way of learning the things. Okay, so that's the example for reinforcement learning. So this is very broader aspect, so I have made it very simpler for you. What you can do is you decide what actually you would like to do. Okay, so based on that you decide what you need to learn. For example, if we are going ahead with robotic stuffs and all, you have to go ahead with reinforcement learning. Suppose if you are doing customer segmentation, you have to go for unsupervised. In unsupervised there is something called clustering, you have to go ahead with that kind of stuff. Okay, so you have to decide what actually you are doing, and then you should be able to decide what kind of thing you should be doing in machine learning. Okay, so hope you are getting my point. Okay, so for example, if we are doing some big data visualization, so then you should go for unsupervised. Okay, so if you are going for fraud detection, credit card fraud detection, then you should go for classification. So same happens for cancer diagnostics and all. Okay, so that's the idea of this image. Now question comes, what if we don't know anything at all? So there are like hundreds of sensors, so all sensors will generate data, or like there are hundreds of people who will generate a lot of data from their phone, and we don't know anything, whether we want to label them or not. Labeling is a very tedious task. What to do? We have unsupervised, like unstructured data. I don't have any structure for that. So this is the example for deep learning. Okay, that is like collecting all the books in a library and piling them together at a particular location and trying to learn something. Okay, so that's the example for deep learning. So unsupervised, unstructured, unlabeled. So this is the idea here. Okay, so this is where we call it as deep neural networks. Okay, so this is how actually it looks, deep learning. So if I have to put it in a very simple picture, this is the best picture I have got it. Okay, so you look at it as a car. Okay, so when somebody looks at this image, you will identify it as a car. But the point here is, get a guy from Amazon who has never seen a car and show him this image. Will he figure it out that it is a car? No. Why? Because there is no deep learning from him regarding the car. Okay, so you are identifying this as a car because you have seen hundreds of images of car since your birth till now, and you have been deep learning regarding that, and you have lot of different types of cars are also available in your labeling in your head based on your deep learning. See, for example, in cars also there are classification like hatchbacks, sedans, like that. Okay, so even now you can, looking at this, you can also figure it out, like what kind of car is this, because in your brain you have a deep learning model. Okay, so based on the data collected, your brain tries to figure it out. Suppose if there is some new car comes, recently Tesla announced a pickup truck which is of very abstract shape. Okay, so if you look at that, any person who was very scratch, who is looking into the car for the first time, he not figure it out. So this is the idea of deep learning looks like. Okay, so again I'll just give you another bad example. People appreciate this, that's the reason why I share this. Suppose if you want to understand women, okay, so you have to meet like every possible woman you come across so that you can understand woman like that. Okay, so or like if you want to understand a man, so you have to meet many people to understand what like man thinks like. Okay, so that's the idea of this deep learning is. Okay, so now we'll club everything together, whatever has been learned till now. Okay, so first point is IoT, in the sense we have to access the data. So data will come from sensors, data will come from files, data can also come from the databases, something like Amazon. Okay, then you will analyze the data, you will do some deep learning stuff and all, you will do some supervised, unsupervised learning. Okay, so based on the domains you can have some specific algorithms for that. Okay, then you will develop some AI model based on your need. Okay, so then you will model it out, so simulate it. Then you will deploy it, in the sense you will come up with a model which can be deployed to some. Okay, this is the idea. Okay, so here are the few steps. First you will choose the data set, then you will massage and clean it, then you will split the data into training set and test set, then you will apply some algorithm, then you will score and evaluate. Okay, so this is very hard to understand. I'll give a simple example. Imagine like you want to teach fire, like fire actually hurts for a kid. Okay, so whenever something you touch hot, like stick, something like that, so you want to teach your kid that like it hurts. Okay, how will you choose that? First you have to choose the data set, what you will get it. For example, you can take a burning wood, you can take some agarbatti, so you can take some burning plastic, you can take some burning iron rod. Okay, so you can take some burning cloth. Okay, out of them you will collect lot of data set, in the sense you will collect everything whatever burns. Okay, so that is an example for data set. Then you will massage and clean it, in the sense you will not take consideration of everything. See, for example, you cannot take plastic for teaching kid how it works, in the sense how it burns, something like that. So the reason why we cannot take this is it becomes kid will hurt in a very bad way because of that plastic burns. So that's the reason you will take only example of agarbatti for him. So that's the point of massaging and cleaning. You will avoid what is not necessary. Okay, so you have collected everything whatever burns in this world, but you have taken only few things. Okay, so that is about massaging and cleaning. Then you will split it into data set and training set, in the sense you will take agarbatti as a training. Okay, then after that you will take a burning wood stick as a test set, in the sense you will teach him by agarbatti, then you will give him a burning firewood. Okay, so then definitely he should be able to deny it. Okay, so if he denies it, that like testing has been done in test set. Okay, what's the algorithm for teaching a kid how to burn his hand, something like that? Just put the agarbatti, burn like the burning agarbatti on his head, like on his hand for 1 second. Okay, so it hurts him. Okay, it burns his skin. So that's the algorithm. Okay, so then you are scoring and evaluating. So based on the amount of time you have placed your agarbatti on his hand, so you can decide like how much he screams, how much he laughs. So that will be your scoring and evaluation method. Okay, so I hope you got this steps in machine learning. First you will have training data, so all the burning candles, all these things will come under training. Then what you do is you will train the machine learning algorithm. Okay, so that is training your kid. So then you give some data, whatever you have collected, massage, clean, and give it to it. Okay, so once you model the data, okay, so then you will get something called machine learning algorithm. Then what you will give is you will give new input data. So instead of giving agarbatti, you will give me a firewood. So if whenever you give him a firewood, if he screams that like it hurts me, then you have a successful model. If it does not scream, then again whatever the model which you are training with, algorithm which you are training with, is wrong. Again, like burn him with a new idea, like new model, something like that. Okay, so again test it for again firewood, again check for the prediction. If it works fine, else again like, so if everything is fine, finally if he screams for whatever things hurts as fire, then you have a successful model. Okay, so this is the idea of machine learning, creating models. Just I'll move to some demonstrations now, right now. So this is one of the AI model called Things Translator. Whenever you show a particular thing, something like hand and all, so it will look like, analyze it, and it will tell you like whether it is finger, something like that. It's not object detection, it is like things translator. Okay, so it will predict what is there in the image and it will do it. So the beauty you have to understand here is this model resides in the JavaScript, in the sense this model, AI model, will run inside a browser. Okay, so that actually works using JavaScript. Okay, all the machine learning stuff is there in JavaScript, and it uses the computer processing power of my computer. I'll just show you. It will open my webcam right now. So I have to just hold this button. I'll just share the presentation later, you can give a try. So if I touch something like this, so it says like black hair. Okay, so I'll just make it easy for you. What actually it detects is it as a black hair in English. So if I go and change the language to Hindi, so if I touch over this and if it captures, you can see it is predicted that like there is 80%, 7% possibility of black hair, 68% of a paint because of my chair's cover. Okay, then there is a wallpaper like behind, because of some drawings and all, it is identifying that also. Okay, so it has detected as paint. Paint, the equivalent word for paint is rang in Hindi. Okay, so I'll try with the hands right now. Now you can see it detected it as a finger. Okay, so this is a what I am trying to demonstrate here is I am showing you a trained AI model. So the model is ready. Okay, I am not training it right now, so it has been already trained for a lot of possibilities of hair, later lot of possibilities for fingers, lot of possibility for paint and all, so already being done. So now what we will do is we will go ahead and one step ahead and we'll create a model here. Okay, so we'll create a model and we'll see how actually this models works and all. So we'll do similar to this. So I'll just open the link. So the example is something called Teachable machine. So you can just follow the instructions if you would like to try it later. So I don't think this will work very well in your phone because it needs a lot of computing power. Not lot in the sense, at least like 4, 5, 6 GB of RAM. So the first thing is you have to click on this get started. Alright, then I'll go ahead. Okay, so what right now this Teachable machine supports audio project, post project as well as image project. Out of them I'll go ahead with image project. So because we are trying with image project, first thing is in Teachable machine we have to specify the class. Okay, so that's what we are trying to do. We are training it. So what I will do is I'll take the current scenario of Corona itself. So what we will do is we will identify persons with mask and without mask. So very simple example. So we can upload the images. Right now I'll try the webcam itself. Okay, so with mask, without mask. Okay, so we can add more classes also, something like half mask. We can try this also. Okay, so but right now I'll ignore this. Okay, because it takes a lot of time. So with mask, without mask, what I'm trying to do now here is I'll make it clear. I want to have a machine learning model which will take the input from a web camera, preferably webcam. It has to identify whether I am with mask, without mask, with lot of samples. This is not actually image recognition. Okay, so this is machine learning which will take lot of samples like 50 images, then it will learn from them, then finally it has to detect it, then you should be able to export it. Then once you should be able to export it, you can just take the trained model and dump it in some Raspberry Pi or even Arduino. Then you should be able to identify the faces. Right now I cannot do all that procedure, but I can give you an idea of creating a model and exporting a model and how to export that model into IoT. So we shall have a discussion on that. Okay, so right now what I will do is, first task is we have to give some samples. You can see here I have something called add image samples. Okay, so I'll just zoom it a little bit so that you can see it. Okay, so I am having something called image samples. Okay, so this image samples I have to add it. So what I will do is I will add it from the webcam. So what I will do is I'll open my webcam. Okay, so you can see like it can see my face. Okay, so what I will do is I will just hold it to record. Once I hold it, I can tilt my face. Okay, so I have 100 samples of images. Okay, so once I done with this, so that is for with any angle of my face I have 100 images. Okay, so in the sense 100 samples. Okay, without mask. Okay, because I'm without mask in these samples. Okay, So here we will make it as with mask. Sorry for the labeling. Okay, so with mask. So what I will do is I will wear the mask right now. So once I wear the mask, so again I will click on the webcam. What I will do is I'll just give some samples for it with mask. I'll just hold to record. I'll just move my face. Okay, so just because people will show the face in all directions, so that's the reason I have given 162 samples of with mask. Okay, so this is the idea. I hope you are getting my point. So right now I have only two classes, one's with mask and without mask and with mask. So what I will do is I'll just train this now. Okay, so I have to give this 100 images of without mask like and with mask. Okay, so 162 samples. All these images are extracted, all the characteristics will be extracted, then it will try to self-learn on its own, then it will try to predict whether I am wearing it mask or not. So it's similar to this image. Okay, so I'll just give you an idea. I hope you remember this cat and dog idea. So what I'm trying to do is similar to this. Okay, so only thing is instead of cat and dog, I am here with mask and without mask. Okay, so now I'll click on hit on trade model. Okay, so once I click on this, it needs lot of computing power. Okay, my system may also a little bit hang for this. So it will take all the images like 100 plus 162, that is 262 images. It will rip them apart. It will take the RGB of each of the pixels. It will try to understand what's the idea here is, and it will try to do it 50 times like that. Okay, so and you can also see like it will say something like don't switch tabs. Why it says like that is like the training should not be interrupted. Okay, so there are few fallbacks regarding the machine learning models. Okay, because as it requires high processing power and all, so that's the reason I suggested you to do it in a laptop rather than a mobile phone. So I'll just wait for it to complete. You can see like if I show you my task manager, it's like almost full. Okay, the reason is like the model is, so now the model is being trained. So you can see like there are some echo box, backsize, learning lit can be under. So even if you are interested, you can go just under the hood and calculate the things, how things work and all. Okay, so finally I'll come to the right hand side part. Okay, so right now it is predicting the things. Okay, so I'll just reset my zoom. You can see just looking at my live mode, you can just see whenever I look into my webcam is open. I am not actually looking into my webcam, I just move my face as it is. So it is saying without mask. Okay, then if I just take the mask and just put it over my face, you can see it will turn to with mask, without mask, with mask. Okay, so it will use something called TensorFlow for this behind the scenes. Okay, so very straightforward learning mechanism with without mask like this. Now what I can do is, so this is of no use in the sense, say for example this works very well in my computer, but what if I want to place this above, like opposite of my house or like at entrance of particular college or a company. Okay, so what we have to do is we have to click on this export model. Okay, now you can see I can export this as a JavaScript. I can have a machine learning model which works on JavaScript, that is any browser. Okay, so any like machine or any microcontroller, microprocessor which supports browser can run this. Okay, similarly I can have a TensorFlow model for this. Okay, I can use Python and run this on Raspberry Pi, something like that. Even I can use something called TensorFlow Lite. Okay, so using this we can have an Android app for this. Okay, so like this you can have a attendance app for your own, something like that. Okay, so that's the idea. Okay, so I hope you are getting my point. So what I did is I took some input samples in the sense like fire burning for a kid, something like that. So we have taken samples. So I took the samples, then I trained it. Okay, so once my computer is trained, then I checked it whether it works fine or not. After that, then I exported it as a model. Okay, So then once you click on export model, you can have it, you can download the model. Okay, so then you can go ahead and explore the things. Okay, so you can try this on your own. It's not that hard. Even a very basic computer science knowledge will help you to do this. Okay, so once you download it, you can download it as a copy in your PC, then dump this in your any IoT devices. Okay, so this is the idea of how Teachable machine works, that we created a machine learning model which will predict whether somebody is wearing a mask or not wearing a mask. Okay, so similarly you can do something, someone is using a sanitizer or not, like using some smell sensor, something like that. Fine. So the next step is how to deploy this AI model into IoT. Okay, so the idea here is I have to take this AI model, like whatever we have created, in the sense whether without mask, with mask, then I have to put it into the IoT device. So just the best example for this is rockets. Okay, suppose if your machine learning model is very small, if the payload is very small, there is no need of having a very high computer, like in the sense very high processing computer. Suppose if your machine learning model is very huge, then you need a very good computer. See, right now that's the reason this machine learning model is working in my computer, because my computer is sufficient enough to run that. So microcontroller for lighter tasks, microprocessors for heavy tasks, both are IoT devices only. Then what we can also do is, suppose if you work on any model using Google Colapse in TensorFlow, you can migrate that the same to TensorFlow Lite. Okay, so there are mechanisms in Google TensorFlow documentation, you can explore that. So you can convert the TensorFlow, like original TensorFlow Lite, so that you can use it in a smaller devices like this. Okay, so don't assume that whatever works on your computer will work on Raspberry Pi or Arduino, because they have very limited processing power. Okay, so the next point here is sometimes we use something called hex dump. Okay, so instead of putting it as a coding directly into the Arduino, we can make a hex dump of the same model. Okay, so that will be easier. Then you have something called quantization, so I'll explain that further. Okay, so to give an analogy to make you understand what actually is going on, your computer is something on the left hand side, your IoT devices are something like on the right hand side. Okay, so you as a computer, whereas your IoT device is something like your kid, something like that. Okay, so your IoT device as a kid is having very small processing power, small capabilities. Okay, so the best idea is you have to pack your machine learning model in a just small trolley like suitcase, so that it can easily drag it and get the things done. Whereas in your case, you can have a very big computer on your own and handle the things. Okay, but this will be not useful. For example, if you carry this bag every time, so it will be very heavy. So the best idea is to put it in a very small portable box. Okay, so next comes whether there are some challenges in implementing this AI to IoT devices. Okay, so the first point here is size of the models. Okay, so size of the models in the sense every byte matters. Okay, so if you take this Arduino and all, if you look at the size of this Arduino and all, it has very limited memory, in the sense maximum of 1 MB is allocated for you. Okay, so whatever machine learning models which you do in TensorFlow and all, there will be of more than 200 MB, 250 MB, something like that. But for this Arduino, only 1 MB is allocated. Okay, so now we have to take care of every bytes. Okay, so that it will fit into this Arduino. Then the next problem we have is this is underpowered microcontroller. Okay, so it does not throttle like your computer. Okay, so what actually our computers will do is they will run in a very basic mode. Suppose if you push it to very hard, right now I am pushing it very hard, so now my computer fans turn on, it will clock the CPU at higher rate. Okay, so these all things will be done. Maximum RAM will be allocated, those kind of things will be done. But that is not possible in this microcontrollers, because it is having very limited device capability. That should be also taken into consideration while implementing this artificial intelligence or machine learning models into IoT. Okay, then there are some big libraries like TensorFlow, PyTorch and all. There are some mini models also. Okay, so you should be cautious whether that fits into that particular IoT device. Okay, so the best way to suppose if you want to avoid problems, I suggest you to take your AI or machine learning model, directly dump it on Raspberry Pi. So Raspberry Pi is the safest option because it behaves like your computer exactly in a miniature model. That's it. Okay, so that's the idea here. Okay, then comes, there is something called quantization. Suppose if you are working on some images, okay, so this images, what we can do is, if you want to try to identify some meaningful pattern in the images, now they have got some concept called quantization. So what actually this quantization does is to identify whether there are trees or like human beings in this image, how many pixels are sufficient, in the sense like how much of pixel data is required. Okay, so we can strip down, suppose this 24-bit pixel image, original image, is equivalent of your phone's image. Okay, so then if you strip it down, you can make it as 8 bits. So 24 to 8 bits will save a lot of data. Okay, so even if you strip that down back to 1 bit of data, like if you make it as grayscale and do the analysis and all, again you will strip down from 24 to 1 pixel, that is you will save 23-bit pixel data. Okay, so you may be wondering how the hell this actually makes a difference. We are just talking about one image. Okay, so any 24-bit image, okay, it will actually minimum of 200 KB, something like that. So if you keep on calculating it, imagine like you have a training model where the training has to be performed for 10 lakh images, 10 lakhs into 200 KB. Okay, so that is huge. That becomes a very like high payload for a particular IoT device or like any microcontroller or microprocessor which are having low power devices, Okay, so the best idea is to quantize the data. Okay, so you have to strip it down so that it becomes very easy for the low power devices. Okay, so this actually in turn is connected to some concept called edge analytics. That is, instead of taking an image, nowadays what actually they were doing is, I'll give an example. What actually they were doing is, they will storing all the photos of the students in the cloud. They were taking pictures from the Raspberry Pi using camera. They were sending that image to the cloud. Cloud was actually verifying whether the particular person is matching or not. Then it was sending a call back to the device. Then that device was actually telling you whether things are fine or not. Okay, so that was actually having previously. So now to avoid that, what this suggestion is done is, instead of storing the students photos in the cloud, you can store all those students photos using this quantization kind of techniques into the device itself. Then device directly will identify whether particular person matches or not, then only upload the data yes or no, that is binary 1 and 0 for a particular student to the cloud. So this will, instead of sending 100 images, you are just sending only 10 KB of data, something like that. Okay, so 100 images, like even if you take 500 MB, so it will come up to 50 MB. Instead of 50 MB, you can just send 5 KB or 50 KB, something like that. Okay, so that's a huge saving on your miniature IoT device part, as well as you are saving money on the cloud also. Okay, so and then comes in what way you can get started. Okay, so I am coming in your perspective. So for beginners, okay, what you can do is you can try out with some tool called Weka. Okay, so you can make a note of this. I'll share this presentation anyhow later. Okay, so for those people who are trying machine learning for the first time, or like if you are getting started, you can just try with Weka. You can try with Weka is based on Java. Okay, Orange. Okay, Orange is like it supports Python also. Then there is some tool, another tool called H2O. H2O is a little bit like hard to get started, but this Weka and Orange, you can start with any kind of machine learning models, any kind of supervised or unsupervised reinforcement. You can play along with this. Okay, so there are a lot of beautiful examples available also, and documentation is very beautiful for both of them. Okay, then you have something called intermediate. Okay, suppose if you are very like well versed with your machine learning stuffs, like you got to understood whatever I said today in one shot. Okay, so then obviously like you are very good with machine learning basics, then these two will not be of that helpful. Okay, so then you can jump ahead and start scripting. Okay, so you can code in Python, you can code in JavaScript. Okay, so you can take use of something called TensorFlow, you can use something called PyTorch. There are many libraries available. Okay, so you can use Java, like you can use JavaScript and Python. Okay, so that is based on TensorFlow. So if you are intermediate, okay, suppose if you are very advanced learner, in the sense if you want to make some research in kind of machine learning, okay, so you can go ahead with Python also, so that will also suffice. Most of people are going ahead in this area regarding machine learning. So suppose if you are very advanced, so if you are would like to use, if you can use also R for machine learning stuff. Okay, so MATLAB is also having some beautiful libraries supported. Okay, so this is for these people who are looking into the area of research, something like that. Okay, for a beginner, I strongly suggest to go ahead with Vega and Orange, understand what is going on, then you can go ahead and do the things. Okay, so then recommended languages. Okay, so same goes as the last slide. For a beginner, you can go ahead with Python. Python is like universal language right now, so it's better like if you can just learn Python. Then we have something called JavaScript. So for those people who are would like to implement some web-based applications using some cameras and all, okay, so JavaScript using HTML5 will make the things easy. Then if you are into research, you can go ahead with R also. Then what are the tools you should play with? Okay, so the first tool you can just play with it is Teachable machine. Very simple, straightforward tool. You can just train the model and you can use it in your project, okay, or even in any IoT device. Then you have something called Google Colabs editor. So if you are looking for online editor, I personally suggest this because your code resides in the cloud and all the computing power will be provided by the Google itself. There is no need of having a PC or good PC, something like that. You just need a computer which runs a browser. Okay, then you have something called Jupyter Notebook. So this is also popular, but you can download all the libraries and all offline, and you can play with the machine learning models, training the machine learning model using offline methods. Okay, then you have TensorFlow and other libraries. Okay, so you can just explore them and you can go ahead with that. So anything can become smart. The idea is just very simple. Anything can become smart. So it can be anything. So for example, it can move from cameras till your exhaust fans. It can be vacuum cleaners, anything. Okay, so anything can be smart. The only provided condition here is either it should have a microcontroller or microprocessor inside it, a small chip, okay, which is able to connect to Wi-Fi or even to Bluetooth, some kind of thing. Okay, so then you will have a smart devices. So this smart device is not only applicable for home, it can be extended to the whole city. Something like drones can be used to monitor traffic. Drones can be used for monitoring any riots happening on the road, something like that. So this is one small example where agriculture based TensorFlow based classification has been done. Okay, I'll just give an example of this. I am a son of a farmer. I know the pain of sorting the things. Okay, so whenever you harvest a tomato, cucumber and all, so the main point here is we actually sort them in a particular separate buckets, so based on their size, length, color, something like that. So it's a tedious process. Okay, so this is a small model, so it will identify its length, size and all. So based on the machine learning model which has been trained, so it will push in a particular basket where it belongs to. Okay, so the classification of products using artificial intelligence can be done. Okay, so this is an example for smart AI devices. So then this is one of the best TED talks you can watch. Okay, so I'll just share the presentation. You can just have and watch this. So self-driving cars. Okay, so how self-driving cars actually sees the world. So you can go and explore this, then you will get an idea how all the devices in a particular car will assist the car to make the decisions, how you can enforce new rules. Okay, how you can take the existing data. Okay, then how to play in the sense like how car should play itself. Okay, so that all things will be covered in this here. Okay, so you can right now, I hope you can see this image on the left hand side. This is how actually normal road looks. This is how the road looks for the car. Okay, so everything is an object for a car. Okay, So that's a basic idea which has been engineered in the self-driving cars. So this self-driving cars use the machine learning models. So based on the machine learning models plugged in, so they will try to identify the objects on the road using some cameras, then they will decide it. Then we'll see what are the challenges to build this smart AI model like IoT devices and all. So the first task we have to is build the trust. Okay, so if you go ahead with the car, which is a very basic model, machine learning model is implemented in particular car, it becomes very hard to build it, hard to trust it easily. Okay, so similarly same happens for your phone. Suppose if you have any new machine learning model which is in a very novice way, so not being tested properly, so again there is a trust issue, like apps data will be shared, something like that. So then there is a possibility of software malfunction. What if you are flying in an aeroplane which is powered by artificial intelligence, suddenly the machine learning model is not trained for a eagle which will come and hit the aeroplane, obviously there will be a problem. So after malfunction will happen. Okay, so then understand it can replace only certain tasks. So most of the people will think that jobs will go off, something like that. So that's a very rare case, it's about so but right now it can replace only certain tasks which are tedious, boring for human beings, but eventually things will go off. Say for example, there were cashiers, now there are checkouts without cashiers. Okay, so things will replace the guys. Okay, but point here is they can replace only certain tasks, not everything can be done by the machine learning because it's in a very crude format. So then we have very high expectations, like for example, I am the person who have very high expectations of AI. I expect it to do everything. I expect it to come make it play the song whenever I enter my house, like that. Okay, so high expectations. So then this is one small scenario just for fun I'm sharing. Okay, so we have a concept of self-driving versus self-killing cars. Okay, suppose there is a self-driving car which does not have any driver or which cannot be overridden by a human being. Imagine there is a hacker who has a tuxnet, botnet will be introduced. Okay, so then they will hack it, they will send a signal to machine learning models that they have to accelerate by 80 km/h without any convention. So this will create a chaos in the traffic. Okay, so this is more worse than the bad drivers. Okay, so all cars instantly starts moving at 80 km/h. There is no control over the car, so that may happen. Okay, so that's an example of danger. Okay, so this is one small image. Okay, so this is where we are. If you take IoT device which has the capability to apply lipstick to a particular girl, which does the makeup, so this is where we are. Okay, so this is the problem is. Okay, so this is where we are, in the sense that we are in a very crude format. Okay, still this machine learning models has to be trained a lot. So there are a lot of scenarios, things will go wrong. Okay, all that has to be taken into consideration so that we can really implement the self-driving cars and all. Okay, so I am expecting that to come before I die. Okay, so at least I want to would like to have one car which actually self-drives itself. Okay, so it's a long journey. Okay, but things will eventually change. Okay, see, when cars were introduced during industrialization, there were people who were hating cars. Okay, so eventually everybody started loving car as time goes by because of because when cars were introduced for first time, people actually were feared that it will have accidents, they may burn to death, something like that. So eventually they got to know that cars are safer. Now everybody would like to buy a car. Okay, so it has become a statement now. So similarly, this AI IoT devices with AI will become a norm. Okay, so it's just a matter of time when people will accept it wholeheartedly. So this is one of the best research paper I have read in in terms of machine learning and IoT. Okay, so I'll share this URL with you. The name of this research paper is Synthetic Sensors. You can imagine to what extent you can take a particular small device of 20 rupees, to what extent you can use it in a home. But the beauty of this research paper is it has shown the potential of machine learning, because IoT devices were just sitting in a corner of your home, something like your goodnight liquidator, which will just sit in a particular plug board, and it will just sit there as it is. Okay, so this research paper will show you what machine learning can do for the existing IoT devices. Okay, so the idea of this research paper is you don't need to eliminate the things. See, for example, most of the people who wants to have a smart TV will sell their old TV. So this is not the point. See, for example, actually because he has already bought a TV of 1 lakh, just because to have a smart things to be played on his TV, he is again investing another 1.5 lakh to get a new TV. So that's a loss of 2.5 lakhs for one particular person. So this is a very bullshit idea. So similarly, washing machine is already there at your home. There is no need of like buying a new washing machine. That can be eliminated with a simple concept of this machine learning. Using existing devices at your home, we can apply machine learning models so that it will like help you in the households. So I am just visioning a smart environment, like how things will fall after 2050 or even 2100. Okay, so if you are lucky, if you are like into this era, so whenever birth get registered, okay, directly what happens is whenever a baby born, automatically a particular Aadhaar number along with the particular insurance will be generated for it. Okay, then based on the locations, okay, so based on the devices at his home, based on the parents data, based on the hospital's data, they will do the analysis and all using the IoT devices, using machine learning and all. It will suggest a school for him, that is like he will have a mobile or like he will have a tab with him. So then it will suggest a school, best school in his area based on the financial condition of the parents also. Then it will also suggest a notification, like notification will come, this is your best friend, go and meet him, because every data whatever is collected is already being distributed to everybody. Then similarly, once he completes a school, based on their parents and his performance in the school, college suggestion will be done. So then there will be boyfriend and girlfriend suggestion will also be like done instantly. Okay, so then based on the college like performance, college like where he is willing to, what his interests are, then based on his interest, job suggestion will also be done. Okay, so everything happens automatically because of the data collected based on his phone. Okay, then they will also like it may suggest, like artificial intelligence machine learning models may suggest whom to marry. So that's another point. So job suggestion, whom to marry. Then when to have kids, like based on their financial conditions, based on their interest. Okay, so when to have kids. Then once they have kids, they will start from the loop 1, birth gets registered, then they will start with their life. But these guys who are having the kids, then they will become old, then they will get a notification regarding which robot to buy to help them. Okay, so then it will also suggest like there is no point of like living with the parents and all, that will be gone by 2050. So then it will also suggest what is the best old age home will be there, which we can live in peacefully. Okay, so then one fine day, imagine like that guy like our girl is very like because of age factor and all, he falls on the floor. Okay, but imagine like he is having some waistband or like wristband, some Apple Watch kind of thing. So instantly, because of his pulse rate or like because of a lot of sensors available in the IoT device, that is smartwatch or smart band, instant call will go to the ambulance. Okay, so instant call to the ambulance, this ambulance will come instantly to his house. All the parameters of his phone along with his watch, medical devices will be sent to the doctor. Doctor will be ready when he goes to the hospital. Okay, imagine like he is beyond recovery. Okay, so if he gets well, no problem. If he goes beyond recovery, and again there is a notification will be sent to the cemetery guy who will be managing that. Okay, so then that will show that like based on the height, based on the width of a particular person, again it will also make the fire or like even the things ready for him for his cremation. So this is how your smart environment will go in the future. Okay, so in a nutshell, you can choose what you are good at. Okay, so learn machine learning and AI. This is unavoidable. Like I sometimes I say something like machine learning is a new computer science. Okay, so there is no point like in avoiding this. Okay, anyhow this will come back to you. Okay, so then try prototyping with the TensorFlow, Arduino and Raspberry Pi. Okay, Then you can use some cloud platforms, something like Firebase. Okay, so you can use those. Even I think there is something called ThinkSpeak. Okay, so that can be used for storing and processing. Then you can try multidisciplinary models also. Okay, so you can try this multidisciplinary model so that things will fall into place based on your research, something like that. You can collect the data from agriculture or even from the databases from government. Okay, so you can apply some machine learning models. You can come up with something which has been never thought of. Okay, so one of the research paper which I studied is he is trying to solve poverty using geographical database, just using the satellite images. So that is also possible using machine learning itself. Okay, so you can try it out. Okay, so next suggestion is think out of the box. Okay, so natural streamline way of handling the things will not work. Okay, so don't try to improve the candle, look for like LED or CFL bulb. Okay, so what actually I'm trying to do is I just scratched the tip of the iceberg. Okay, so there are a lot of things which I'm also learning in machine learning. So I'm also experimenting with a lot of IoT things. Okay, so I'm just scratching the tip of the iceberg. Okay, so there are a lot of references which I will share with this presentation, so you can explore it so that you can get connected with the next steps. Okay, so it will be shared this on the slide share. Okay, so you can play with the AI models. Okay, so I hope this was helpful for you. Thank you for listening. Over to you, sir.
Yeah, thank you, Praveen sir. Am I audible, sir?
Yes, sir. Go ahead.
Yeah, thank you very much, sir. It was a great session today. We came to know about a lot of new things today. That is about the two websites which you shared with us. That was really excellent, and which was actually new to us. Now, if participants have any queries, you can post your queries in the chat box, and if you want, you can unmute your mic and you can ask, sir.
Yeah, it's better like if you compose it in a chat. Like there is one question like by Shubham, can botnet be used legally? Or it like actually depends on the constraints of the country. Okay, so I cannot like just say like botnet can be used legally. There is one conference called DEFCON. You can make a note of this. I'll just spell it in the chat. So there is something called DEFCON. Okay, so you can go to this website or explore this in the YouTube videos. Okay, so actually most of the botnet stuffs are illegal as of now. Okay, it depends on your country, sir. Like in some countries it's acceptable that like you will help the things to enhance the security. In some countries it's totally illegal to get into somebody's phone or even somebody's device. Okay, so it's country specific, I can say. Yeah, Sumitra has questioned that like teachable machine codes can be copied. Is that code available with the trained data? Yes, ma'am. Like if you download it, so you have an option like whether you would like to download with the trained data set. Like you can include the data set or you can exclude the data set. That is also possible. Okay, so trained data set model will be exported to you. So that is a point. But if you want the data set to be along with that model, that is also there. Like they will make some particular folder for that. Everyone and everything is connected. How about the security? That's a beautiful point. The point here is, see, you like connect it with everybody. Okay, so everybody shares with everyone, but your bedroom stuffs are not shared. So it depends like whom you would like to share your data with. So there is one particular company called humanity.co, something like that. So they are working on this. Like what they are trying to do is they are selling human beings data, in the sense I can decide my data as a property. That means Google has to pay me to use my data. So that is being trying now. Okay, so that is like how I treat my property. See, for example, this is my car, this is my property, this is my land, this is my farm, or something like that. So in next 10 years, something like that, concept will come something like this is my data, in the sense Google has to pay me some amount, or Google has to come up with some rules, terms and conditions, so that they have to communicate with me. Okay, so in that, if I give consent only, then they should be able to get the data from me, else they should not be available like that. Something like leasing your property, something that is a how. Okay, a scientist killed using AI technology, I don't know, like I have not been through this. I am not actually a news person. Okay, so we don't have DTH at our home, even I don't look at the news. So the only way, like I know that earthquake is coming by WhatsApp, or somebody will call me and tell me like you have to run away. Okay, okay, so this is my websites, like I write about computer science. Okay, so I write about anveshanya.com, like about life and all, how regarding things called God things and all. So you can explore there are things on my website also, so you can explore the presentations also. So this is my contact numbers as well as email ID. Okay, so if you want to personally connect and have a queries, you can drop a mail. The disclaimer here is I am not the expert in all of the technologies. Okay, so based on my learning experience, like experimental experience, so I may come up with a conclusion for you. So I can just strip down your like learning and exploring time.